This is problem 1430. It's on page 612. Two small spheres, A and B, are made of different materials and have the weights indicated. They are moving on a frictionless horizontal surface with the velocity shown when they hit each other. Knowing that the coefficient of restitution between the spheres is 80%, determine A, the velocity of each sphere after impact, and B, the energy lost due to the impact. Okay, so let's start off with the first part. We've got sphere A, ground, here's sphere B, and it's a 6-pound A and a 2-pound B. 8 feet per second is the initial velocity of A to the right, B 12 feet per second to the left. Now, the first part is to determine the velocity after impact, and that's pretty straightforward. I know some of you said you've already done this and some of you haven't, so please verify that the answers I've got are right. We're going to do the normal thing. We'll set up our momentum equation. So mass of A times the velocity of A initial plus mass of B, velocity of B initial. We're going to set that to the final momentum because understand that the impact force that's generated between the two bodies is internal to the system of the two bodies, and so its impulse cancels, right? Because the impulse of A onto B is equal to the impulse of B onto A, and so this is a common trick. We pulled it several times. Okay, but you'll notice that there are two unknowns. The two unknowns in this equation are the final velocities. Now we know the initial velocity of A and B. Notice that the momentum of A would be positive, the momentum of B would be negative if we take a positive x-coordinate, say, to the right. Okay, but we still have one equation, two unknowns, and that's where the coefficient of restitution comes into play. So the coefficient of restitution, what it really gives you is the ratio of the final to the initial difference in velocity, in other words, relative velocity. So what it gives you is, and it doesn't matter which order you write this in, you can write VB prime minus VA prime, but you have to flip the order in the denominator, so VA minus VB. Okay? So it's the relative velocity after impact divided by the relative velocity before impact, and there's a negative sign thrown in so that E comes out positive. Okay? Now E, this is not the special number in your calculator. Okay? In our case, this is 80%. Okay? So notice we've got the same two unknowns in this equation, and we can solve. Let's go through that quickly. We'll solve for this and then be done. So let's see, probably the easiest way to do this, if we rearrange this equation, we can then plug it in and solve. So we'd have E VA minus VB plus VA prime equals VB prime. All I did was multiply the denominator on both sides and then move VA prime to the other side. And that way, since this is VB prime, I can plug this in for the velocity of B after impact. So then our equation would look like this. The initial momentum of the system is equal to mass of A, velocity of A after impact, and remember we're just getting rid of the velocity of B after impact. So then plus mass of B, velocity B after impact, we're going to substitute in. So the coefficient of restitution, VA minus VB, let's put a minus sign in there, plus the velocity of A after impact. Okay, so now what we want to do is solve for the velocity of A after impact. I'll do that a little more slowly. VA plus MB VB equals, if we pull this out, what would we get? Let's see, we have mass of A. Now, understand this mass of B is multiplied by these two terms independently. So VA prime, when we pull it out, we just get mass of B. Okay? And then the term, so we've got this term and this term. The one that remains is this term. So plus MBE VA minus VB. Okay? Now if we want to solve for VA prime, then what we'll need to do is move this term to the other side. So mass of A, velocity of A plus mass of B, velocity of B, in other words the initial momentum, minus the mass of B, E, VA minus VB, just moving this term to the other side, and then dividing all of that by the multiplier on VA prime, MA plus MB. That would be the velocity of A after impact. Okay?
I have a question.
Sure.
When you factor VA prime out,
Yep. Right here.
wouldn't that be equal MA plus MV times E?
The E is on this. Did I make a mistake? I don't think so. The E is just multiplied by the denominator. So VA prime is just added to this whole thing. Right? So since it's just added, then I think it's just MB times that.
Oh, okay.
Good question. Anything else? Okay, so now let's plug in numbers for this and see what we get. So the mass of A, all the units are consistent, right? So we should get the velocity out in feet per second. The only place we have to be careful is to make sure we put in positive velocities and negative velocities appropriately. We're not just going to put in 8 there and 12 there. This is going to have to be a negative 12 because it's going that way. That makes sense? So we have to be careful with that. So the mass, let's give ourselves some space here. The mass of A is 6 pounds. The velocity of A is 8 feet per second, plus the mass of B is 2 pounds. The velocity of B is negative 12. Okay, so that's these first two terms. Minus the mass of B is 2 pounds. E is 80%. The velocity of A is 8, minus the velocity of B. Be really careful here. The velocity of B is a negative 12. Okay? Understand, this is the relative velocity before impact. What is the relative velocity before impact? 20 feet per second. Right? So minus a negative is plus a positive, so 8 and 12 are 20. So that takes care of the numerator here, divided by the mass of A plus the mass of B, that's 6 plus 2, equals VA prime. And the sign will come out naturally. If we get a positive number, then that means that the velocity of A after impact is to the right. If we get a negative number, then the velocity of A after impact is to the left. Okay? So let's see what we got. 6 eighths are 48, minus 24. This is 20 times 2 is 40. 80% of 40 is 36. If I'm doing the math right in my head, over 8. Correct me if I get this wrong. I'm still half asleep, I think. So 36 and 24 are easy to add. That's 60. So we've got negative 60. So we've got, what, negative 12. So negative 12 over 8. So 3, 4, negative 3 over, let's see, 2. Negative 1/2. Is that right?
We actually
I messed
got
up
negative
some.
1, but it came up to like negative 8 over 8.
Negative 8 over 8. Where did I mess up here? Because 24 and 36. Yeah, I probably messed up somewhere doing that, the math in my head. So you say it's negative 1? Okay. Sounds like we got people second. Thank God for calculators, right? What's that?
Oh,
The 36 plus 32.
32, okay, so that's where I messed up. Okay, so negative 1 foot per second, that means the velocity of A after impact is this way. So let's just draw it here. VA prime is negative 1 foot per second. So now how can we calculate the velocity of B after impact? Well, it's quicker just to go through this. I wouldn't go through this equation to do it. It's going to be longer. I'll just use this since it's already solved for. So 80% is E. The velocity of A is 8 feet per second. The velocity of B is again negative 12. Let's see, plus the velocity of A after impact. Well, that's a negative 1. All right, so 20, 80% of 20 is 18, minus 1 is 17. Did I do it right that time? 17 feet per second?
Yeah, 15.
You got 15? I still did it wrong.
80% of 20 is 16.
You're right. There's my problem. Okay, so 15. I'm calculator dependent and proud of it. So the velocity of B after impact is 15 feet per second. Okay, now that's not the part that you asked about, but I thought we should go through all of this for the sake of the video. the question you asked about was part B, where it says calculate the energy loss due to the impact. Well, the way to do that is to calculate the amount of energy before impact and the energy after impact. And that's pretty straightforward. The energy before impact, let's just say energy in state 1. So this is state 1 up here, and down here is state 2. The energy before impact is just 1/2 mv squared. And probably what you're thinking is, how do I plug in a velocity because I've got two of them? Well, it's easy, you just add them. So velocity of A plus 1/2 mv velocity of B squared. So these are velocities before impact. So mass of A is, there it is, 6 pound mass. Be careful, we don't want to plug in 6 pound force. The equation calls for mass. The velocity of A is 8 feet per second. That needs to be squared. Now notice I've pulled out the half. Plus the mass of B. The mass of B is 2 pound mass. The velocity of B is 12 feet per second. It does not matter that it's in the negative direction because it's going to be squared anyway. Okay, so let's see what we get for the energy before impact. 8/8 are 64 times 6. I'm not going to do that in my head. It's too early in the morning. You do it. What do we have for the energy before impact? Does anyone agree with that? Yeah. Second? All right. 336. What are the units?
Joules.
Joules?
No, I'm sorry.
Thank you. I'm glad you said you were sorry. I will chastise you heavily on exams for that. You're right in the sense that it's energy. Okay? Now is the time to say that. The exam's the wrong time to say it. Okay? Joules are units of energy, you're right. But they're not the same size as the units of energy we have here. What units of energy do we have here? It's easy. It's pound mass, feet squared per second squared, which are not units of energy you're used to. You may not be used to any units of energy yet, that's okay. But something like pounds force feet would be units of energy that would be valid for the English system. So all we have to do is multiply by 1 pound force per 32.2 pound mass feet per second squared. And look what happens. The pounds mass go away, and all the feet per second squared go away except for one of the feet. And we end up with pounds force feet. Okay? Now you don't have to do this. In fact, let's delay this until the end. So let's leave the pound mass foot squared per second squared alone. Okay? I heard a bunch of erasing as soon as I said that. Sorry. And let's calculate the energy in state 2. Now I'll go ahead and write it for the sake of the video, but I'm not going to say anything, so you guys that are in the class, don't look up here for a minute, and you calculate the energy in state 2, and let's see if we do it the same way. Okay? All right, so here we go. Tell me if you agree with my answer or not. Is that right? still working, so I'll wait for a moment. You mean I got a number right in my head this time?
I was thinking that.
Maybe I'm awake now. Okay, all right. So the energy loss is just the difference between the two. Would just be E1 minus E2. Because we had E1 before impact, we have only E2 after impact. And so that difference must be the amount of energy that's lost. So that's what, 8? Is that right? Okay, so that's pound mass, foot squared per second squared, but we would actually like to have foot pounds force. So you convert this to foot pounds force for me, please. Now I've got to say pounds force feet, because foot pounds force sounds like a torque. It's interesting that the dimension of torque and energy are different, but the units are the same. How much?
3.35.
3.35, thank you. So there's the amount of energy that's lost. Does that answer your question? Bless you. Any other questions on this problem?